Hello everyone, welcome back to my YouTube channel. This is part 2 of the topic irrational numbers. Today we'll be discussing about properties of irrational numbers and decimal form of irrational numbers. So let us start. Let us discuss some properties of irrational number. First property states that when we add or subtract a rational number and irrational number, the result is always irrational number. Second property states that when we multiply or divide a rational number with irrational number, the result is always irrational number. And third property states that when we add, subtract, multiply and divide two irrational numbers, the result can be either rational or irrational. Let us see some examples. The first example here is 2 plus root 3 plus minus root 3. Now 2 plus root 3, this is an irrational number. Minus root 3 is also irrational number, and we are adding both the numbers. Now here third property will work. Addition of two irrational numbers can either be rational or irrational. So your plus root 3 and minus root 3 will get cancelled. So our answer will be 2, which is a rational number. Let us have a look on second example. 4 root 5 divided by root 5. So 4 root 5, which is an irrational number, divided by root 5, which is again an irrational number. So we'll use third property. When we divide two irrational number, the answer can be rational or irrational. So if we divide this, root 5 and root 5 gets cancelled and our answer becomes 4, which is a rational number. Third example, 3 plus root 5 minus root 5. Again 3 plus root 5 is irrational number, root 5 is irrational number, and subtracting it we get 3 as root 5 plus root 5 minus root 5 gets cancelled. Fourth example, 2 root 3 multiplied by root 3. Now 2 root 3 is an irrational number and you are multiplying it with root 3, which is again irrational number. So answer can be rational or irrational. Root 3 into root 3 is 3 and into 2. So your answer will be 6, which is a rational number. So in this case, two irrational numbers, if you multiply, you are getting a rational number. Let us discuss next example. Here also you have two irrational numbers, root 5 and root 2, which are multiplied, and answer is root 10. 5 2 is 10 and root 10. Now root 10 is irrational number. So in this example you see, when we multiply two irrational numbers, the result is rational number. And in this example you can see, when we multiply two irrational numbers, the result is irrational number only. So property 3 works here. Last example is 2 root 5 minus root 5. Now here only root 5 is there, it means it is 1 root 5. Nothing is there means it is 1. So here we can take root 5 common. So 2 minus 1 and root 5 is common. So 2 minus 1 will be 1. So your answer becomes root 5. So here also third property we have used, that when we subtract two irrational numbers, the answer is irrational or it can be rational. In the first example we seen it was a rational number. In the last example we seen it is a irrational number. Now we have to prove that 3 plus root 5 is irrational number. To prove any number to be irrational, we have to prove that it is not a rational number. So it will be indirectly prove that it is an irrational number. So for this we apply some steps, like we first assume the given number as a rational number. So let us assume 3 plus root 5 is a rational number. So if it is a rational number, we can express it in the form of numerator upon denominator. So therefore we can write 3 plus root 5 is equal to p upon q. Root 5 is equal to p upon q minus 3. This 3 will shift to right hand side. So root 5 is equal to p minus 3q upon q. Just did the cross multiplication. So here we can say that p, q and 3 are integers, not rational number. Yes, they are rational number, but we'll say they are integers. Therefore right hand side is a rational number as it is in the form of p upon q. Since p, q and 3 are integers and it is in the form of p upon q, that is numerator upon denominator, we can say that this right hand side is nothing but it is a rational number, that is q. Q is the symbol for rational number. Now from this equation we observe that since right hand side is rational number and right hand side is equal to left hand side, so this equation states that root 5 is rational number. Root 5 is rational number. But we know the fact. What fact? That root 5 is irrational number. So from this equation we come to know that root 5 is rational, but the fact is that root 5 is an irrational number. So from this conclusion, the conclusion is that this equation contradicts the fact that root 5 is irrational number. So we can say that 3 plus root 5 is not a rational number, it is an irrational number. Now to prove root 5 is an irrational number, we have to do another steps. Like in the previous video, we have proved how root 2 is a irrational number. In similar way, we will prove root 5 is a irrational number. But in this sum, we'll directly mention it as a fact that root 5 is a irrational number. We'll not prove it again and make the sum lengthy. Next is decimal form of irrational number. Now this is a most important part of irrational number, that is a decimal form. And you know that irrational numbers are non-terminating, non-recurring numbers. So the digits after decimal, they are non-repeating as well as they are non-terminating. So we have to find here, the first question is to find the square root of 2 using division method. So there are some rules to find this square root of 2 using division method. So let us start solving. A simple division method we will use. So let us start. I want to find the square root of 2. Now after decimals there are many numbers, infinite numbers. If you want two numbers, then here after decimal you will put two sets of zeros. So this is one set of 0 and this is another set of 0. If you want two digits after decimal, you will put two sets of 0. If you want three digits after decimal, you will put three sets of 0. So here we will solve for three decimal places. So I have put here three sets of 0. Now the next rule is that whichever number you are writing here, that same number should be here. For example, if I am writing here 2, so here it will be 2. Now 2 2s I will give you 4. But 4 is greater than 2, so it is not applicable. So we will use 1 here because it is the smallest number which we can use now. So I am writing a 1. So 1 ones are 1, and now you can easily subtract it. 2 minus 1 will give you 1, and these two zeros will come as it is, and we'll put here a decimal point. Now the next rule is that we have to divide this again 100. The next rule is that whichever number is there here, you have to double the number. Now here 1 is there, and double of 1 is 2. And the next number which we'll be writing here should be same which I am writing after decimal. Now suppose I am writing 1 here, so it is 21, and here also it will be 1, so 21 ones will be you 21, which is not near to 100. Then next number I am writing 22, so here also I should write 2. 22 2s are 44, which is not near to 100, right? So I have to write that number which is near to 100. So let's say I am writing 4. So 24, and here also 4. 24 4s I will give you 96, which is near to 100. So this will be my correct digit, that is 4. Again 100 minus 96 will be 4, and again we will put this set of zeros here, so it will be 400. Again the same method. Now whichever number is there here, now don't count that decimal. So the number is 14, we have to double that number, it is 28. And now the third digit will be same as we are writing after 4. So now we have to think which digit we should write. Let us start with 1. If it is 1, so it is 281, 1s are 281. If it is 2, 282 2s are, so it will be greater than 400. So 1 is a perfect number. So 281 1s are 281. Again we will subtract, and what you are going to get, this is 9, 1, and this will be 1. So 119 we will get, and again there will be this set of zeros here, right? Now again the same method will proceed. Now we have to see these three digits 141, and we have to double the digits. So what will be the answer? Double of 141 will be 282. Now we have to select such digit, that is a fourth digit, which will be similar to this. Now 282. Let us start with 1. So 282 ones are, it will be 282, which is not near to 11900. 282 into let's take the next number 2822, and here also we'll take 2 if I am writing here 2. So if you multiply it with 2, you will get 4 4, 2 8 are 16, 1 carry 5, which is 5644, which is not near to this 11900 we want. So we cannot take 2 here. Let us take 4. If you are taking 4 here, same digit should be there here. So 2824 multiplied by 4. 4 4s will be 16. So 1 carry. 4 2s are 8 9. 4 8s are 32. 3 carry. 4 2s are 8 and plus 3 will give you 11. So it is 11,296. Okay, it is close to this 11,900. Now we'll just see for 2825. 2825 multiplied with 5. 5 5s are 25. 5 2s are 10, 11, 12. 5 8s are 40 and carry 1, 41. 5 2s are 10, carry 4, 14. So it is 14,000. So means here the correct digit will be 4, because if you take 5 it is exceeding 11,900, and if you take 4 it is smaller than 11,900. So our next digit will be 4, and here it will be 11,296. Now since we have taken 3 sets of zeros, we got 3 digits after decimal. If you want the fourth digit, again you will take one set of 0 and you will solve. So this will continue, and the answer will be, the digits after decimal will be infinite. So this is how we solve the irrational numbers with division method. So similarly we can solve it for root 3, root 5, root 7 and so on. So let us solve one more example of square root of root 3. So same procedure we will do. Now here I will find only 2 digits after decimal. So let us see here 3, and after decimal I will put 2 sets of zeros, since I want only 2 digits after decimal. So same thing we will do here. If I put 1, 1 ones are 1. If I put 2, 2 twos are 4. So 4 will be exceeding that 3, so we'll put 1. So 1 ones are 1. And here I will get 2, 3 minus 1 will be 2, and these two zeros will carry here and put a decimal point. Now it is 200. Now we have to do the double of the first digit. So double of 1 is 2. Now second digit we will select such that it will be same here, and it will be less than 200. Let us say 25. If I am selecting 25, so here I should write 5. 25 into 5, it will give 125. Okay. If I am selecting 26, so 26 into 6 will give you 6 6 are 36, 6 2 are 12, 13 14 15, 156. Okay. So 25 will be not there. 26 6 are 156. Okay. Let us see for 7. 27 into 7. 7 sevens are 49. 7 twos are 14, and plus 4 189. Yes. So 189 is close to 200. If you take 8, it will be greater than 200. So here the correct digit will be 7 and not 5 and not 6. So let us write 27, and here second digit will be 7. 27 sevens are 189. Now again we will do subtraction. So we will get here 11. Again we will carry this 0 here. Now we want such a number which is less than 1100, and here we are going to do double of 17, that is 34. Now we have to find the third digit. The third digit here and here should be same. So let us see 1. So 341, ones are 341. It is very less. 342, let us see. 342 into 2. So you are going to get 2 2s are 4, 4 2s are 8, and 2 3s are 684. Okay. Let us try for 242 into 3. 3 2s are 6, 3 4s are 12, and this 3 3s are 9 plus 1 10. Yes, 1026. So 2 will be not there, 1 will be not there. I think 3 will be there. Because if you multiply with 4, it will be greater than 1100. So third digit will be 3. So 343 into 3 will give you 1026. And similarly you will solve. Now here I have taken only uh, two sets of zeros, so after decimal I got two digits. If you take another set of 0, you will get the third digit, and similarly you will get the fourth, fifth, sixth digit, and so on. Since this root 3 is a irrational number, it is a non-terminating, non-repeating type, so there will be infinite numbers after decimal. And this is the way how you solve how you found the decimal form of root 2, root 3, and you can also find for root 5, root 7, root 8. I hope you understood today's lecture and found it interesting. So do like, share and subscribe our channel. Thank you.